Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 128, locate the centroid, bar x, bar y of the beam's cross-sectional area, and then determine the product of inertia of this area with respect to the centroidal x prime and y prime axis. So here is the given figure for our solution. Let's divide the component rectangles into this manner, horizontal here, as shown. So the area here is 10 mm by 100 mm, so 1000. So this is 300 minus 10, so 280 times 10, so 2800 area. Then this one is 200 by 10, so 2000. So for solution, area is equal to 1000 plus 2800 plus 2000. Therefore, area is 5800 mm square. By Varignon's theorem, to solve for bar x, area times bar x equals 1000 times 50 plus 2800 times 5 plus 2000 times 100. So 50 is one half of 100, one half of 150. One half of 10 is 5, that's why this is 5, and one half of 200 is 100, that's why that's 200. So bar x is equal to 45.517 mm. Then similarly, 5800 bar y equals 1000. The distance of the centroid of this area from the bottom is 300 minus 5 mm, so 295. While the bar y of 2800 is, by symmetry, it is half of 300, so 150. And bar y of 2000 area is 5 mm, half of 10. So 5800 bar y equals 1000 times 295 plus 2800 times 150 plus 2000 times 5. Solving for bar y is equal to 125 mm. So by transfer formula, the centroidal product of inertia of each rectangle is 0 because both axes are symmetric. Therefore, the only component of the product of inertia would be that area bar x bar y. So to be consistent, the bar x should be x coordinate of the centroid of the area minus bar x, and the bar y would be y coordinate of the centroid of the area minus bar y. So therefore, ix prime y prime for the first area is 0, then area 1000, quantity 50 minus 45.517, quantity 295, its y coordinate minus the y bar y. So the x coordinate of the area minus bar x to be consistent. Then plus for this area here with respect to the centroid 0, then plus 2800, bar x 5 minus 45.517, bar y 150, 150 minus 125. Then plus 0 plus 2000, bar x 100 minus 45.517, bar y 5 minus 125. Computing ix prime y prime equals 15, negative 15.15 times 10 to the 6 mm to the fourth. Level 129, determine the product of inertia of the shaded area about the xy axis. So here is the given figure. For this problem, let's treat it as we have big rectangle, then less this rectangle here. The dimension of the big rectangle is 140 mm by 80 mm, so the area is 11,200 mm square. For this smaller rectangle, 120 by 60, so it is 7,200 mm square. The location of the centroid of the bigger rectangle is here, so that is 70, and this is 40. 70 half of 140, 40 half of 80. Then for the centroid of this smaller rectangle, it's here. So that is half of 120, 60, and half of 60, 30. So 60, 30. So with respect to the centroid, 0, then we only have area barred x barred y as the part of the moment of inertia which has value. So 11,200 barred x is 70, barred y 40, then minus 0 plus 7,260 times 30. So computing Ixy equals 18.40 times 10 to the 6 mm to the 4th. Level 130, calculate the product of inertia of the shaded area about the xy axis. So here is the given figure, and we treat this as semicircle, then rectangle, less this triangle, because for this triangle orientation, we have a formula for the product of inertia Ixy, and it is b square h square over 24 as our guide. So for solution, that's the formula for the triangle oriented in this manner as shown. So it may be in this triangle here, this hollow triangle, and that one. So b square h square over 24. And if you want to verify that, you look at the preceding slides that I uploaded, and you look at that situation there, or you may derive it again here. So it is moment product of inertia of semicircle plus product of inertia of rectangle with respect to the xy axis, then minus the product of inertia of this triangle. Since the semicircle and the rectangle have axis of symmetry, then their centroidal product of inertia would be 0, leaving only the portion, the other part, area barred x barred y. So the location of the centroid of the semicircle is here, and from the diameter 4r over 3 pi. So the barred y of that semicircle would be r plus 4r over 3 pi. Its barred x is just r. Then for this rectangle, barred x is r, barred y is r over 2. And for this quarter circle, there's no need barred x barred y because the formula is automatic for that orientation. So Ixy equals 0 plus pi r square over 2, semicircle, barred x r, barred y r plus 4r over 3 pi. Then plus the rectangle with, with respect to the centroid 0, plus area 2r by r, then barred x r, barred y r over 2. Then for the triangle, minus b square, where b is 2r, h is r. So 2r square, r square over 24. So computing each value using the calculator, 2.2375 r to the fourth, then the second is r to the fourth, the third is r to the fourth over 6. Then combining and expressing the answer in decimal form in terms of r to the fourth, Ixy equals 3.071 r to the fourth. Level 131. Using the parallel axis theorem, determine the product of inertia of the area shown with respect to the centroidal x and y axis. So here is the figure. So the location of the centroid of this semicircle is here. From the x-axis, 4r over 3 pi, 4 times 6 over 3 pi, 4 times 6 is 24, divided by 3, 8. So 8 over pi, positive. And its barred x is positive also, 3 inches, half of 6 inches, because take note, the centers, this is 6 inches, and therefore this is the in between So that's why that's 3 inches. That's also 3 inches. So 8 over pi, then this is also 8 over pi. For this semicircle here, below the x-axis, the barred y is negative 8 over pi. So remember that these semicircles have axis of symmetry, therefore their centroidal moment product of inertia would be 0. It's only the area barred x barred y part which has value for the product of inertia with respect to the xy axis by transfer formula. So Ixy, considering this first, is equal to 0 plus area pi 6 square over 2, barred x 3, barred y 8 over pi. Then for this area, with respect to the centroidal axis 0, so plus 0, then pi 6 square over 2, barred x negative 3, barred y negative 8 over pi. So this is positive, this is also positive. So we combined Ixy equals 864.0 inches to the fourth. So that's it, and I hope that your knowledge on product of inertia or of inertia in general have been added for future problems in engineering.